Why, hello! My name is Miss Townsend, and I love math. Welcome to Math with Townsend. This video is for grade 10 students who are studying a wonderful thing called quadratic relations. Right now, we're looking at some word problems in which you're not given the equation, rather you have to develop the equation and then solve. And from that worksheet, this is question number 4. Number 4. Here's the question. It says the hypotenuse of a right triangle is 15 centimeters. The other two sides have a total length of 21 centimeters. Find the lengths of the other two sides. Okay, so let's think about the question before we immediately start writing stuff down. I need to find the lengths of the other two sides, and we're dealing with a right-angled triangle. Okay. So any old right-angled triangle, there we go. We know the hypotenuse is 15 centimeters, and we're supposed to find the other two sides. Now, normally, you can talk about C and A and B, whatever you want to call them, it really doesn't matter. So normally at this point, we think about what equation we're going to use. For example, if we're talking about a rectangle, we often talk about area as length times height. If it was the area of a triangle, we would probably use base times height divided by 2. But this isn't an area question at all. In fact, this question is talking about the hypotenuse of a right-angled triangle. So we're going to have to use some sort of equation that relates the hypotenuse to the other sides. I'll let you think about that for a moment. In the meantime, let's start defining our variables. Again, when I read the last sentence carefully, find the lengths of the other two sides, it gives me a hint about what my let statements should be. So I'm going to let A be one side. In fact, let me just make this clear. I'm going to let A be one missing side. And again, we're measuring in centimeters. And we're going to let B be the other side. The other missing side, because it just sounds weird to kind of say the other side because it implies there's only two, and we all know there's three sides to a triangle, so that's why I threw the word missing in there. So let A be one missing side, let B be the other missing side. Now, first of all, we need to find, because we've defined two variables, we need to write an equation that relates those variables to each other. So what do we know about the relationship between A and B? We know that the other two sides, meaning A and B, have a total length of 21 centimeters. In other words, we know that A plus B totals 21. So there's my equation that relates A and B. And again, anytime you define two variables, you need to have a relationship that connects them to each other. Now I need an equation that connects A and B and the other piece of information, the thing that I know. I know that the hypotenuse is 15. And I know that in a right-angled triangle, A squared plus B squared equals C squared. Remember the lovely Pythagorean theorem. So that's the relationship between A, B, and the side that I know, the hypotenuse. So I'm going to write that. A squared plus B squared equals C squared. Now C in this case is the side that I know, so I'm just going to say 15 squared. So A squared plus B squared equals 225. So I would like to be able to solve this equation, but I can't solve it while it has two unknowns. So now I'm going to use this equation to get rid of either A or B. In other words, we're going to substitute out. So another way of writing this relationship, let me see if I can snag this. Cool. Another way of writing this relationship would be to say that B is equal to 21 minus A. And this is a nicer way to write the relationship because it tells you exactly how to find this if you know A. And that's a more powerful tool when we're doing equation solving. It says if you know what A is, here's how you find B. So this is what we call an explicitly written equation. I know exactly how to find B if I know what A is. So this is also important to us because now I can do a substitution because I know what B is. So that means I can write something instead of the letter B. And let's go ahead and do that. So we're going to do a substitution for b so that hopefully we end up with only one unknown. So b is now going to be replaced with the substitute 21 minus a, and now I have what I was looking for, a single equation with only one variable, and now we have to solve. So after all that, we again come down to just, here is an equation, do the math. So first of all, we know that we need to multiply things out, collect like terms, and so on. So let's go ahead and do FOIL on this bracket. So FOIL, or square the first, double the product, square the last, which is what I like to do. So when I do FOIL on it, I'm going to get 441 minus 42a plus a squared, and all of that is equal to 225. So I'm actually going to have 2a squared plus, nope, let's put things in proper order. So 2a squared minus 42a plus 441 equals 225. And of course, in order to solve a quadratic, it has to equal 0. So I will subtract 225 from both sides, and that gives me 216 positive. So there's my equation. So now I can try factoring if I want, or let's go ahead and just use the quadratic equation. So x equals negative b plus or minus the square root of b squared minus 4 times a times c. All of this is divided by 2a. Okay, so be careful, watch your negative signs. Minus a minus means positive 42. Let's calculate the discriminant. So 42 squared, subtract, bracket, 4 times 2 times 2, 16, close bracket. The discriminant is 36. That's nice. That means I could have factored it, but whatever. And so now we'll split into two possible answers. One where x equals 42 plus 6 divided by 4, and one where x is 42 minus 6 divided by 4. So here I get x equals 48 divided by 4, and here I get x equals 36 divided by 4. I get two possible answers for x. So let's see. Now neither of them are negative, so I can't instantly say inadmissible. So I have, oh, good heavens. Okay, so major communication faux pas. Pardon. This was the letter A, so this should be the letter A. Yes, yes. You would, of course, take your eraser because you want full communication marks. Okay, there. All done. Now, here I discovered that A was equal to 12. And if A is equal to 12, I have to go and tell you what B is. So again, what's the relationship between A and B? B is 21 minus A. So if A is 12, B is 21 minus 12, B is 9. So in one scenario, I have side lengths of 12 and 9. Here, if the side length is 9, again, calculating B, I get a side length of 12. So here I get side lengths of 9 and 12. Now, these are the exact same triangle because there's no difference in a right angled triangle. There's no immediately discernible difference between side A and side B. Um, the hypotenuse certainly is clearly identified, but there's no reason why A has to be the long side or the short side. So these are in fact the same answers. So my conclusion is therefore the other side lengths are 9 and 12 units, let's say centimeters. Okay, so you never just look at your answers and automatically cross one out without thinking first. Um, Always say, well, if this is true, what happens? And does this make sense? If this is true, what happens? And does this make sense? And in this case, they both make sense, but they're actually the same answer. Okay, I hope that helps, and I'll maybe perhaps see you on the next video.